Good morning. I'm from JD, in charge of the engineer architect. Today I'm going to talk about large-scale Kubernetes clusters, management and operation of JD. There are three parts in my speech. So current status of Kubernetes clusters in JD, and second, how to optimize it. The third part is the daily operation of Kubernetes clusters. The first part about our private cloud container technology. Starting from 2014, we began to use container technology, and we have JDOS 1.0 at the first half of 2014. And it was began to be used in the 18th June 2014. We migrate to the container platform, and the business was used by using the isolation between containers. In 2015, we basically achieved the full containerization. In 2015, the two major promotion festivals, we achieved the full implementation of JDOS 1.0 and accumulate many experience. And we achieved the container distribution second level escalation and combining with Docker. I think you might all know that we have a scale-up container in 2016. Since we investigate Kubernetes technology in 2015, in 2016, we have a whole new resources platform combining with Kubernetes technology. Same in 2016, we began to establish our ecosystem, combining the network storage, monitoring, log collection, kernel technology, etc. So the whole ecosystem was done by our department. Some of them are tailor-made using open source technology, and some of them are independently developed. During this period, we also built a large-scale calculation platform and the image center in 2017. The JDOS 2.0 using Kubernetes technology was launched. And it was the world's largest Kubernetes cluster, and we achieved second level scalable of this platform, and it was full process achieved on the platform from source coding to encoding and to packaging, from the hours level to minutes level to seconds level. And in 2018, we have JDOS 3.0, and it was a PaaS platform. The resources can be allocated more intelligently. This is the self-developed components of JDOS 2.0 platform, including container LB. It was based on DPTK high-performance load balancer. Was one of the best solution in the industry, and also container DNS. It's a high-performance DNS service developed by us, and also application release services. We offered quick online scaling up and down and grayscale release, etc. and also the rollback of versions. At the same time, there are also monitoring service from resource monitoring or method monitoring and alarming service based on monitoring index, and then container logs. It collects logs. This system is developed by us. It can quickly search or setting alarms or long-time storage of logs and image service. By using CDN acceleration and other technologies to quickly distribute images in multiple cities, multiple data centers. Image scan technology can safely scan images. And the most important part is the resource service for the bottom level of Kubernetes resources. That is the overall management of container resources. We allocate quotas at different level, and we calculate and manage resources for different departments and applications on different levels. We will send the bills to our customers and how they use the resources to help them enhance the utilization rates, and also CI/CD service. CI/CD service, it was an independent service based on Jenkins. It can support horizontal scaling and encoding service for thousands jobs at the same time, and it was introduced by my colleagues recently. Currently, this is the status quo of clusters. We have around millions of containers online. A single Kubernetes cluster have over 9,000 nodes, over 20,000 online services and applications. All the services, shopping malls, logistics, big data, etc. All those services, they are fully containerized. And operation and management status quo of cluster, the daily delivery achieved 10,000. Each department's operation and maintenance, they can reach 10,000, and special operators, 2 of them, and clearance of the warnings can be done daily. And about the optimization of Kubernetes clusters. Kubernetes, we are using the version 1.6. And we have tailor-made based on version 1.6. We investigate in 2015 why we stop updating them, following the community, since there's newer version like 1.10 or 1.11. After reaching such a large scale, it's impossible that we keep following the updating speed of the community. What we do is, based on the tailored version 1.6, we will keep tracking the updates of Kubernetes community. If there's functions that is highly related to our services, then we will go to update that to our production environment. And configure map optimization. I believe if you use this configure map in the Kubernetes, well, you will be familiar with that. When a cluster scale reaching such a level, each node will run tens of containers. If each containers amount of different configure maps, that is configuration file, that will cause problems. Each configure map in default setting, every few seconds, it will ask for APSO for dynamic mounting to mount it to the pod. This will give API server a very high pressure. Take 1,000 nodes cluster as an example. If there's 25,000 containers, each pod will have 10 configure maps. Then there will be 250 QBS, and every 5 seconds there will be a request. Then the API server or etcd will have a large pressure. What we do is that in terms of the dynamic mount of configure map, we will divide them based on our business need, business demand. For parts that doesn't need dynamic mount, we will remove that function. If there is a demand for dynamic mount, we can click on that and choose to use that function. By analyzing our logs, after this operation, the request will be reduced by 99%. Then the scale of the cluster can be increased, but of course there are more optimizations can be done. And also fully use labels. Labels can be used on computers or pods. In the production, we are using these labels. First is nodes, its property, including CPU model, disk type, rack, where it belongs to, and the pod where it belongs to. It's the part of the data center related to the network infrastructure. And resources related, we have zones. We divide different zones, different IDC, and the status of node and its image status, network status of the node. By managing these labels, we can have a small grainage management on them and the allocation of resources. We also have a resource for pod rebuild. I think this is a quite leading function in the community. Why we have a demand for this? First, when the resources, when there is no much resources left in the resources pool, for updating a deployment, it will destroy first and then rebuild one. If at such circumstances and the resources not sufficient and you need to launch a lot of applications, then the pods will be in pending status. Prioritized pods will not be able to guarantee its resources and will be listed in the scheduling queue. And even if we prioritize pods, we cannot satisfy our customers' demand. That's why we have pod review function. When updating deployment, it will not reschedule. Instead, based on the original status, it will upgrade in place. There are several benefits brought by this function. It can prolong the network resources lifecycle, since it will not reallocate our hosts. Since it also only updates the backup of the image, then the rebuild speed can be increased, and we reuse the routers. After build the pod, we will release the router, and the pod always has the container. And the pod do not need to release the router, so it will have a better performance. Another thing to share is that we need to carefully use the automatic recovery. It involves Kubernetes several functions. That is soft evacuation and hard compulsory. It's a very personalized function that we can use, but it's not the optimized function in the production.
So we have realized the self-configuration of draining. The groups will be established automatically, and based on their functions, the decisions will be made whether to drain them. If a pod is not required on a host, then we will look at the priority and drain them accordingly. In addition, we have tens of thousands of applications online, so we need to know their requirements. In most of scenarios, the developers don't need self-recovery. What they need is not self-draining. They need to maintain the scene at the site. Next is about the scheduler optimization. As you know, the upstream scheduling has some problems. The algorithm is not optimized. It's just a solution. So based on the scheduler, we have done some customization. For instance, for the algorithm, we have done the random selection, random sampling to find the local optimum. We don't need a global optimum. Once our cluster has reached a scale like 500 or 1,000 nodes, when we need to schedule a pod, then we don't need to turn to all the nodes, because there will be a waste of resources. Based on this, we can think whether for the scheduling we can reduce the number of nodes. Like every time we just look at 500 nodes to find the scheduling optimum. And after we done that, we have reduced the time from minutes to seconds. However, the problem still remains with the algorithm. When the resources are running out, the local optimum may not be found. There will be a waste of resources and efficiency, but this is very real. And second is the IP distribution of containers. Kubernetes is based on CNN. By using this architecture, in our production environment, we found in terms of distributing the containers IP, this architecture seems to be better. So what we have done is we have developed our original Skynet server, and we have replaced etcd with MySQL. As a result, our speed has reached 2,000 per time. 20,000 per minute. And that is about our daily maintenance and operation of Kubernetes in JD. To ensure the security of components, we have done lots of things. First is we try to decouple the components. Every component must have high availability, and in extreme cases, even there is like 3 or 4 replicas unavailable, there will still be 1 or 2 available. And also we have the monitoring of performance. The status of components are monitored every per second, and we have warnings if things come up. If like the status is not good, there will be accordingly warnings. And in our daily operation and maintenance, we have established some warnings, and we also look at the event and also abnormal parts. These event and part abnormality and also indicators of our clusters. Well, there are several types of part abnormalities. One is out of CPU and out of memory. And the reasons behind that is the scheduling bug. So when we reboot the scheduler's main node, they will not select a fresh node. It will restart the old node. But there is no information. So the resources are 0. There are no resources on the old node. As a result, there will be a wrong distribution. And the Kubernetes will detect this, and it will set the status of node as out of CPU or out of memory, and the part will just be dead. Another abnormality is crash loop backoff. Normally, it's because there are some failures of the rebooting of applications. Now, for these kind of containers, we think it's mainly happens in online, and it's not because of the Kubernetes status. And third abnormality is terminating. Some containers may be the status out of Kubernetes for a long time. This is also an abnormal status for the part. And the reason may be the host is offline or is broken, or the terminating of status of on the host is broken. For example, the volume of mountain is occupied by another application, so the host status is terminating. If things happen, then we need to get back to the root cause and fix the bug. The fourth one is OM killed. And this is mainly because the parts workflow is overstrained. We have a picture here, and it shows the real-time information about the status of parts in Kubernetes. And also you can see the numbers of parts. And through this graph, you can see whether the part is healthy or not. Meanwhile, for all the clusters, we have an all-round inspection. Inspection is very important in the production environment and is based on the accumulated parameters. And these include some not very common kernel parameters and systematic parameters. Here is a list of parameters here, lots of them. And the second kind of parameter is the version of the modules. To maintain the clusters, we have lots of versions, so it's very important to keep this information. And the third is the process inspection. And this inspection is to look at each machine to see whether it's healthy and whether it's operating properly. And we keep upgrading the inspection system. We also use SERV here. SERV can significantly improve the efficiency of inspection. It can converge within a second. The next part is etcd data security. Once Kubernetes reaches a certain scale, it's very easy to run into these issues. So here we look at how we back up the data, and when there is a failure or a disaster, how do we retrieve the data. And here are three main methods. One is read data, just read the raw data. We have compiled a program which can read the raw data directly and then will write into the distributed file system. And second approach is to use the snapshot. And these happen on a very fixed basis. And the third approach is very straightforward. It just copies the directory under another root or another directory and back up in local environment. Here is about the Kubernetes version upgrade. And this is also based on our experience. We're using the computing controller. There are several automated functions when there is a function not ready or offline. There will be some operations in the endpoint controllers. Some functions may be removed, and as a result, there may be some failures. So we have customized the controller, and just for your reference, if you want to upgrade a cluster or a version, so first you need to stop the controller. To avoid some unexpected situations. Second is to stop the scheduler. And the third step is to stop the Kubernetes before you upgrade the Kubernetes or other components. And this is also to avoid the mismatch of the data, and also to avoid some abnormalities of controllers. Here's about the cluster's data visualization. I can skip this because my colleague has already shown this in the flash speech. And here's about how to handle the huge amount of warnings. When our cluster have reached like tens of thousands and lots of clusters, a host may be taken down, and it can happen every day, and it can happen with more than one host. So how can we deal with it every day? And when a host is broken, there will be warnings, of course.
So we do some correlation analysis. Based on the collected monitored data, we'd see if they belong to the same rack or the same machine. And these pods and these containers, are they belong to the same application or in the same host? After the analysis, we reduce a huge amount of warnings. For some P-warnings, it was caused by certain reasons, like online application was not fully tested, and some was some ran into problems, and other containers, other hosts will send out warnings. If we do analysis, then we will locate to see which is the core reason for that warning, and then we can deal with that. And then planning and prediction for content. It's mainly for the two promotion festivals. For now, it's the R&D staff working on it. For most of the time, they don't know how large the container should be. After analyzing the application to see historically during the 18th June or 11th November, how was the container used during that 2 days? And based on that analysis, we can make a prediction on how many and how large the container should be. And after launching it online, we can monitor its utilization rate of resources timely. And all the CPU utilization or disk utilization and the load, etc. We will monitor them and generate a report periodically, just as you can see on the right-hand side, to comprehensively show that how the resources are being used in that application. Thank you very much. If you have any questions, feel free to ask me. Good morning. When you upgrade Kubernetes master, you stop the controller manager first, and then API server. But previous speech delivered by people from Google saying that they should stop the API server first, and the scheduler and the controller manager will be waiting. So is the same? Is that the same? Yes, we skip the part of API. First, you should stop API. If you upload your business platform in API, you should stop that port, and then you work on the kubelets, controller manager, and the scheduler, etc. Thank you. Okay, a quick question. If the Kubernetes cluster is very large, if you stop the scheduler and the controller manager, and will you be needing a very long process when you need to upgrade the grayscale? No, we can control the time for that. During upgrade, we will upgrade the grayscale first. Normally, we will launch several machines in test environments and then put them in the production environment. And also release some in the grayscale. And for the upcoming nodes, they will be upgraded in batches, so it won't take a long time. So first in grayscale and then in batches and large scale. Yes. But of course, we will fully test the version. We will not wait until we finish the update. Will you build a test environment to test the online version? Yes, we have offline testing environments and also online testing environments. For grayscale, because there will be newer version and older version, will there be any problems? We will ensure the compatibility among them. Normally, they are compatible to each other. For the faults and the container site, how will you do that? And second question, after maintaining that site, how will you release the resources? Otherwise, they will take up resources as well. After dropping out, Kubernetes itself has a mechanism. They will keep the container for a longer time. As long as you don't clean them manually, that will exist after leaving the pod. Just for recovery parts, the corresponding parts and the container will be found out, and we gradually recover them. And we also find out the parts that only start less than one time. We will clean them. After recovery, we will start the container. How will you restart the site? I mean, leaving the failed status. You can check the log. There will be documents for checking. For restarted, will it overwrite? No. For all the data in the container and the log, in default, will be sent to the partition that we set for that. For controller manager and the scheduler, if you stop them, will that influence your service request? So new service request, will they coming in? No, we stop the API as well. And what about users, they want to use it? Do we stop users from using them? For API and the scheduler, we will stop the service. How long will you stop that service? Depends on how you revise your version. Normally, upgrades will be done in a short time, so it's acceptable for users, yes. And we will choose corresponding time to avoid time clashes. Final picture saying that the prediction of the resources allocation, I want to know that for some resources, will that be solely occupied by certain node? Will there be any quotas? Or with prediction, how will you manage the resources allocation? What do you mean by, not sharing the resources? Like putting some quota online or CPU occupying certain resources, how will you manage the resources allocation? Well, we can choose the scale before launching. It's corresponding to the limits of Kubernetes. It will not exceed that limits. When many pods are running, they will ceasing for resources, right? No, CPU can separate for different partitions, separate different parts. We saw that in Docker, some of the resources will be solely sent to, you mean CPU set? We already support CPU sets online. Relying on an internal mechanism, right? Based on special scenario, have a stricter requirements on application, we will have CPU set, but for most of the time we will use CPU share. A question, CPU, GPU, disk SD will be divided based on labels, right? Yes. If you're using labels, it's once it will not be recycled. It's not volatile. We will not delete them. We will put it as unschedulable status. And another question, oversells, how you work on that? There is no certain scale for that. Thank you.